Okay, Justin, this will be rather quick. I'm sending you also a copy of just the problem solved, but I wanted to give you a verbal explanation in case you didn't understand what I wrote down in the problems when I solved the problems. Okay, number 9 is like number 12 in lesson 74. These are exactly the same type. It says two 12-sided polygons are similar. A side of the larger polygon is 9 times as long as the corresponding side of the smaller polygon. What is the ratio of the areas of the smaller polygon to the area of the larger polygon? Okay, this is from lesson 5, that's probably why you don't remember it. And what it says in lesson 5 is the ratio of the areas of two similar two-dimensional geometric figures equals the square of the scale factor between the two figures. So what that's saying is if you find the ratio between the sides, so the ratio of the smaller side to the larger side is 1 to 9. That's the ratio of the sides. To find the ratio of the area of the figures, if they're similar, you square the ratio of the sides. I don't know if you remember that from geometry, but we definitely did that in geometry. So you just find the ratio of the sides and then you square it. If we look down here at number 12, it's the same thing. It says the larger side is 3/2 the smaller side. So if we multiply both sides by 2/3, kind of flip it. I think I'm going to have this backwards. Actually, no. If I divide both sides by S sub s, we would get SL over SS equals 3/2. So that's the ratio. That's the ratio of the sides is 3 to 2. So the ratio of the areas is the ratio of the sides squared. So that's how you get 9/4. So that one should be pretty easy, especially since it's from geometry. Okay, number 15. You don't have to do that one. That was supposed to be one that you didn't have to do, but I forgot to not include it. Okay, 16. These are slightly complicated. I told you guys in class what you could do is just use your calculators, but when the base is 7/4, you don't have that option on your calculators to have the base of a 7/4. You have log base 10, and on your calculator, if you have log, that means that it's base 10. And if you have natural log, it means log base e. So these are kind of complicated. What you have to do to graph these is you switch your x and y. So we're finding the inverse function. So I put my x in for the y. And if you want to look this up more closely, look at lesson 85. It gives you a full explanation. So we switch the x and y. This is how you find the inverse function. We did this before. We haven't done it for a while. And then you write your log as an exponent. The base is 7/4. The exponent's always what it's equal to, and it equals y. So we're rewriting a log as an exponent. Once we rewrite the log as an exponent, then we're going to graph it using our chart. So you just need a couple values. Like you always put 0 in, and it's always going to be 1. Always put 1 in, and then it's 7/4. And if you put -1, it's just flipping the fraction, so you get 4/7. So I plotted those points 0, 1, 1, 7/4, and then it would be -1, 4/7. And it's going to look like this. It's never going to touch the x-axis, that's your asymptote, and it's exponential, so it's going to keep increasing quickly. Now, to figure out the log, what the log function is going to look like, you have to switch your x and y values. So your x now becomes 1 and your y becomes 0. So I just switched these all around and plotted those points, and that gives me the log function. And it's always symmetrical over the xy axis. So the steps are exchange your x and y, put it in the exponential function, graph the exponential function, and then flip the xy values, and it gives you the graph of the log function. That one's quite complicated. I don't know if anyone's getting that one right. Okay, let's go on to lesson 74 then. Okay, let's get down to these cis problems. Cis problems, hold on a second. Okay, cis problems. You're multiplying two. These are just complex numbers with sine functions. So if we're multiplying two complex trigonometric functions together, you multiply the numbers in front together. That's how I got 24. 4 times 6 is 24. And you add the arguments together. So it would be negative pi over 3 plus 4 pi over 3. You add those together and you get 24 cis of pi. Because this would be 4 pi minus 1 pi is 3 pi. 3 pi over 3 is just pi. Then you split it up. You have 25, C stands for cosine, pi, and 24, this I stands for imaginary number, 24 sine. I think I forgot the 24 here, but it ends up going away anyway, so let me put it in there. 24 sine. And then you just have to figure out the cosine of 180 is negative 1. And the way you can think of this, if you want to use this kind of table here, is put a point on each place, on each one, going around the circle. This is our unit circle. So this one would be 1, 0. This would be 0, 1. This one is negative 1, 0. And this point is 0, negative 1. Sine is always the y-coordinate, cosine is the x-coordinate. So we know 180 is around here. So the cosine of 180, that would be the x-coordinate. So cosine of 180 is negative 1. The sine of 180 would be the y-coordinate, which would be 0. So it would be I, this is actually 24 times 0. And your answer would be negative 24, written in complex form, would be negative 24, the real part, plus the imaginary part. So hopefully that made sense. Let's go down to 28. Log problems. There's a lot of different miscellaneous problems here. Okay, for log problems, if the number's in front of the log, you have to pop it up on top and make it an exponent. So we're popping them on top. When they're all the natural logs, all the same bases the whole way across, you can kind of just drop them all. But not yet. First you have to combine them. So when they're added together, you multiply the arguments together. The fourth root of 16 is 2. Remember, this means, because in the seat, the fourth root of 16 is 2, x squared. So we're going to combine them on this side, and we're going to multiply, so that would be 2x squared equals the natural log of x minus 6. When you have natural log on both sides, or log base 10 on both sides, or log base 2 on both sides, as long as they're on both sides, you can drop them, and then you set the arguments equal to each other. Now it ends up being a quadratic equation. So you set it equal to 0, factor it, set each factor equal to 0, and solve each of them. You can't have a log of a negative number, so you have to cross this one out. And over here I guess I showed you how to get that. Alright, hopefully you have some understanding of logs. Alright, is there another one down here? Okay, let me just jump over here to number 23, another complex trigonometric problem. Alright, this one is, we're supposed to write 13 cis of 5 pi over 6 in rectangular form. So when you see the cis, you can separate it into cosine of 5 6 pi plus I sine of 5 6 pi, 5 pi over 6. We figured out that if you just use your calculator, this is 150 degrees. 5 times 180 divided by 6. And then over here I did 150 degrees, leaves us 30 degrees. Cosine would be adjacent over hypotenuse, so it's negative square root of 3 over 2. Sine of 30 degrees is 1/2. This would be positive right here, so it's going to be positive 1/2. This was negative because we're on the left side of the origin. And then you just distribute the 13 through, and that's your answer. Okay, 29, another log problem. Things to keep in mind, natural log of e, when the base which natural log base is e, matches the argument, the answer is 1. The log base 10 of 10 equals 1. If I had log base 2 of 2, it would equal 1. Whenever the base matches the argument, the answer is 1. They don't put the base when it's base 10 because that's just like the square root. We don't put the little 2 on it. So the natural log of e is just 1. We're going backwards this time. We're going to take the exponent and put it out front, so we're going to get 4. The log of 10 is what we have over here, is just 1. So it's going to be 4 times 1, which would give us -4, and that will equal -2. Okay, this one we're combining, we're not solving. We put the 4 in front. 4 times 2 is 8. The natural log of e, which we just did in the last problem, is 1. We're putting the 1/2 in front, so it becomes 2. The natural log of e is 1. Put the 5 in front. The log base 10 of 10 is 1. So you just have 8 plus 2 minus 5 equals 5. And the last one, factor over the complex numbers. What we want to do is, if I said to factor like x squared minus 4, we would just say x plus 2, x minus 2. But this is not factorable. There's no way you can factor this. It's not a difference of two squares. There's nothing you can do, but it is factorable over the imaginary number system. So we want to write it as factors, x plus something, x minus something. One way you can do this, you could always use the quadratic formula, but it's not necessary because we don't have a b. When we don't have b in the quadratic formula, you can just put the x squared on one side and the number on the other side. Then take the plus or minus square root of both sides, so you get x equals plus or minus square root of 20, which equals 2 square root of 5i, and then you have to write your two factors, because this is plus or minus here. So you're going to have two factors, so you're going to have x minus 2 square root of 5 and x plus 2 square root of 5. And these are factors just like these are factors. Two things, and we multiply these together. If we were to FOIL these, we would get this, because our outer and our inner would add out. Our first would be x squared, and our outer would be -4 times 5 would be 20. So hopefully that was helpful. We can meet again on Thursday. And hopefully we'll probably have some new problems. Hopefully you understood those.